So in this video we will be looking at the hybridization of ethene and ethine, right? So the formula of ethene basically is C2H4, right? The formula of ethene is C2H4. So now let's define the hybridization, how the structure is arranged, what about bonds in it, right? So let's first find the configuration of C, right? We know the atomic number of carbon is 6. It will configuration will be 1s2, 2s2 and 2p2, right? Over here you can see that this is s orbital, this is p orbital, right? And in this you can see that over here the carbon has valency. Basically the structure of ethene is like this. This is the basic structure of ethene, and we have to make this like this is the line structure. First there is a dot structure, then line structure, and then there is a hybrid structure, right? And so today we'll be talking about the hybrid structure, right? So this is the line structure and we have to make this. So you can see that carbon is forming 4 bonds, right? But over here, like when we see the valency, it can only form 2 bonds. It means that we have to do the excite, like we have to excite the electron from this orbital to this is s and this is p, right? So the s, like the electron that is in s orbital, will be excited to the p because they have nearly same energy, right? Because these both are in same orbital 2, right? So let's find this, and you can see over here this is s and this is p, 1 and 1 1 1 and 1, and now it can easily form 4 bonds. So now what we'll do, we will do hybridization of this. We will do hybridization of this. These both, like this is s and this is p, these both will be intermixed. These both will be intermixed, and then it will form sp3, 4 sp3s. sp3, 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 right? sp4, sp3 will be formed basically. Now the other, we are having hydrogen, right? We are having hydrogen will be 1s1 and just like this, right? So now just make the structure of this, right? So when we make one carbon over here, one carbon over here and other carbon over here, okay, in hybridization we don't show pi bond, and you can see over here, okay, here the actually the hybridization will not be sp3 because here one pi bond is forming, right? One pi bond is forming. One pi bond is forming over here. Like suppose this is s, this is px, py and pz. You can, like in the rules I have told you that pi bond does not participates in the hybridization. So obviously if we are not counting pi bonds, so then how we can count the orbital of the pi? So we won't be counting this py, suppose this py orbital. So according to us, this only ps, px and pz will intermix and they will form the hybridization, which will be sp2. The hybridization will be sp2. And how many orbitals will be formed? Only 3 sp2 orbitals will be formed. Only 3 sp2 orbitals will be sp2, sp2 and sp2. right? Only 3 sp2 orbitals will be formed over here. Why? Because pi bond is forming there, and pi bond does not participates in hybridization, right? So now there are three sp2 orbitals. There are 3 sp3 sp2 orbitals. Now what will happen? Basically, we are having two carbons, right? First of all, they will attach themselves by the sigma bond, right? So now what will happen over here, like we know the shape of hybrid orbitals, right? Now this will form bond with this is like this. You can see over here the orbitals use is both sp3 sp3, both have used the sp3. Now these carbon, like they are done with one valency is over. Now only two valencies is remaining to. Now this carbon will join with, like here we are having hydrogen and hydrogen. Now this carbon will join to hydrogen. How? Like this, like this, like this, like this, basic. And their s orbital, the s orbital of hydrogen will combine s, and here it will be sp2. Here it will be sp2. You can see over here we are having here s is here, right? And here sp2. And you can see over here too that hydrogen's s is combined. You can easily write here, you can easily put here s, right? S, and over here you can write it sp2 and sp2. It means carbons sp2 sp2 is using, I have written here sp3. It is sp2 and sp2. You can easily see. Now we are also having, like we are not forming pi bond, but we are having p orbitals too. Like one p orbital is still remaining, right? One unpaired p orbital is still remaining over here, which is unhybridized. Basically it is unhybridized, and it will come perpendicular to the axis. It will be perpendicular, like 90 degree to the axis. It will be on the 90 degree to the axis. And how it will be forming? It will be forming like, it will form like, oh god, why am I using this? It is perpendicular to the axis, like to the, or you can easily write them like this. Like this, you can write them like this, because they are not part of geometry, they are not shown, but we have to obviously mention because these are unhybridized, so we have to show them. And so this is p, this is p orbital, this is p, and this is p, and they are forming bond, which is pi bond, they are forming the pi bond. So this, you can imagine the structure of of ethene, basically C2H4. And you know what, this p bond, this forms like the structure of cylinder, like it forms the structure of cylinder like this. And you, if you want to like observe the angle, like what will be the angle over here, the hybridization is sp2, it means I have told you this thing that when the hybridization is sp2, the angle and no lone pair is involved in it, so the angle will be 120. So angle will be equal to 120. Let me make this. So angle will be 120 degree. And how I'm finding this angle? Okay, you can see over here by like, let's take another color which is quite vibrant. Okay, you can see over here, here like this, it is forming like this. Now here, see the angle over here is, 120 degree. The angle over here is 120 degree, and same in the terms of this. Here you can see easily that it's like this, and here the angle forming is 120 degree. So it means the angle is 120 degree over here, right? So I hope the structure of ethene, like the hybridization, the whole the visualization is clear to you. And remember one thing, that this pi bond, like this pi bond is forming, this pi bond is forming, and then the p orbital is forming the shape of cylinder, the shape of cylinder in this ethene molecule, right? So now let's talk about acetylene. Let's talk about acetylene, right? So acetylene, right? So now let us discuss first of all the formula of acetylene. The formula of acetylene is C2H2. So this is the formula, and the structure of acetylene is like this: C triple bond C H and over H. So we know the configuration of C, like we know the configuration of carbon, and let's talk about carbon in its excited state. This is S and this is P, right? Over here you can see this as this. This is excited state. This is first excited state. Excited. This is the excited state, right? So like you can see over here, how many bonds are there? You can easily see this is only sigma bond, and sigma bond, and there are two pi bonds. Means two p orbitals are involved in pi bond. So we won't be calculating the pi bond over here. So we will be eliminating two p orbitals from here. So we will only mix S and P. One S and one P. Will only mix S plus P. We will only mix this, and only two hybrid orbitals will be formed like this. And we will, in the hybridization is here, like in acetylene, the hybridization is SP. The hybridization is SP. So now let's just make the structure of acetylene, right? So as you can see over here, we are having carbon atom and another carbon atom. So now let us make the structure of, will form S bond, like the first sigma bond and another sigma. Oh, let me erase this. Let me find it at a distance, right? Okay, you can see over here that now one sigma bond and other sigma bond. Like the sigma bond is clear now, is now done, and here the hybridization is sp, like the sp orbitals are meeting. The sp orbitals are meeting, and every carbon has two sp orbitals, right? You can see over here two sp orbital. One carbon has s2 sp and it has utilized one. Now it will form bond with another hydrogen. It will form bond with hydrogen, right? Like this, and here hydrogen will be s will be here, and here sp is used. Same as in case of this here, and s is used and sp is used. Like this is a basic structure. You can see over here that this is sigma bond, this is sigma bond, this is sigma bond. So now we have to also mention the like p bond. We like they are imaginary, like we have to find show the lines too, right? So let us, first of all, we are having this one, then we are having, see, we are having py and p and pz. So one is on in one plane and another is in on other plane. Let me draw them with other color, right? So you can easily understand. Okay, the color is now like this color, right? Now let's draw this. You can see over here. So over here, right? Now you can see this, that there will be attraction, right? This will be attracted towards this over here, and this will be attracted towards this, and this one will be attracted towards this, and this will be attracted towards it, right? And now like here the bond form will be, this will be pi bond, pi bond, pi bond, and over here it will be also pi bond will be there. So you can easily imagine. Now the thing to remember here is that these pi bonds or the p orbitals, these p orbitals will form the structure of drum. They will form the structure of drum, right? So you can easily see, imagine this, right? So here the bond angle, like we don't, like in geometry we don't count these pi bonds, we'll only count the sigma bond. You can see over here that, let me draw another, this hole, like this is about this hole, like this is forming the linear structure, this is forming linear structure, linear, and here the bond angle is 180 degree, the bond angle is 180 degree. So I hope the structure of ethene and acetylene is clear to you, and it's so interesting to learn.